Good morning all. Let us discuss another problem using Ampere's law. Find the magnetic field due to a toroid. Find the magnetic field due to a toroid. What is a toroidal coil? A toroidal coil consists of a circular ring around which a long wire is wrapped. Toroidal coil is basically a circular ring around which a long wire is wrapped. We can say a toroid is nothing but an endless solenoid. We have seen what is meant by a solenoid in the previous problem. And if you take a solenoid and bend round in the form of a closed ring, then it will form a toroid. Toroid, we can say toroid is an endless solenoid. Take a solenoid and bend round in the form of a closed ring, then we will call it as a toroid. Now we have to find out the magnetic field due to a toroid. The current flowing through the toroid is I. Suppose capital N be the number of turns and let I be the current flowing through the toroid. Here, note that the magnetic field of the toroid is circumferential. The magnetic field of the toroid is circumferential. If we consider a cylindrical coordinate system, then you can have the direction of the field phi, direction of the field B. That is, B is acting along the phi direction. That is, the magnetic field is circumferential. Now, how to find out the magnetic field due to a toroid? To find the magnetic field due to a toroid, we need an Amperian loop. Here, the shape of the Amperian loop is circular. Take a circular Amperian loop of radius S as shown in figure. To find the magnetic field due to a toroid, consider a closed circular path of radius S, that is an Amperian loop. An Amperian loop of radius S is drawn as shown in figure. Then by Ampere's law, closed integral B dot dl, that is equal to mu 0 I enclosed. To find the magnetic field of a toroid, use a circular Amperian loop of radius S, and by Ampere's law then, closed integral B dot dl is equal to mu 0 I enclosed. Now what is the current enclosed by the Amperian loop which has a radius S? Suppose the toroid has n number of turns. Capital N is the total number of turns in the toroid, and the current in each turn is I. The current in each turn is I. Then the current enclosed by the Amperian loop is nothing but Ni. This is because each turn will contribute a current I to the Amperian loop. Therefore, the total current enclosed by the Amperian loop is nothing but I enclosed, that is equal to Ni. Hence, closed integral B dot dl equal to mu 0 I enclosed becomes closed integral B dot dl equal to mu 0 Ni. Now the magnetic field is circumferential and the magnitude of the magnetic field is constant along the Amperian loop. Then you can take it outside. Therefore, B into integral dl equal to mu 0 Ni. Now what is integral dl? Closed integral dl. Closed integral dl gives the length of the Amperian loop. Here the shape of the Amperian loop is circular. Therefore, closed integral dl becomes 2 pi s. That is a circumference of a circle of radius s, integral dl equal to 2 pi s. Therefore, B is equal to mu 0 ni by 2 pi s. Suppose small n equal to capital N by 2 pi s, then we can say B is equal to mu 0 n I, small n I. Now by including the direction, we can say B equal to mu 0 ni phi cap for all points inside the coil, and B is equal to 0 for all points outside the coil.